GP 4.1, 4.2, what are you going to be covering? You need to know two things. It's only two things, but I guess as you're practicing, you may find the first time listening to it may sound a bit funny. But we've got what we call a maximum flow. That's what you need to know. What is the maximum flow? And then minimum cuts. Those are the two. Okay, maximum flow, minimum cuts. Now, here's the logic. I made a video on this as well. There's a couple of videos ready for you. But let's have a think. What is a maximum flow? This is what they're trying to say. When you have two tubes as an example, all right, say water flows through this pipeline, and this pipeline, if it's small, say it can take about, I don't know, 12 liters per minute. Okay, let's just say that was the rate that it can go through. It can't go any more. 12 liters is the maximum it can take. Then let's say that's connected to another pipe that is much larger, which now has a capacity or potential to take on water that goes up to, say, 30 liters per minute. Okay? The question, on a logical basis, I'm not even talking about a theory right now, just logically, what's the max output? How much water can really come out in terms of pressure? So in the first one, 12 liters per minute is maximum. And then going over here, this can take 30 liters per minute. How much do you expect to come out maximum? 12 liters per minute. Why? Yeah, doesn't matter that, yes, this can go up to 30, but if you're only putting in 12, then this will only have 12. So the only amount that you get out is 12 liters. So then what happens if I then connect this then? What if I connect the same minimum pipe and this is also 12 liters per minute? What's the maximum output? 12, very good. And then what if I change that and I said, let's make it smaller. And this only now has 5 liters per minute. What's the maximum flow that will come out? 5. You see, so what's important here? There's a pattern. There's a pattern that out of all the pipes, it's what the smallest pipe connected to each other is. That's the maximum flow that you can get. So yes, this can go 12. Yes, this can go 30. But at the end of the day, you get to this point, that only takes 5. So the maximum flow that can come out is 5. This is why, if you think about traffic, when you drive in the traffic, people are like, oh, just make more freeways. It doesn't matter if you make more freeways, because if you think about it, if the point is this is the city, the more freeways you make, it doesn't matter. If the cars can't come out of the city, if the city has only got, let's say, a capacity of 300, and they can't flow out quickly enough, if you can only have 300 in the city, even if you increase the number of freeways to get to the city, it doesn't matter. Because you increase that could be 50, 50, 50, 200, I don't know. But it's too much coming in, people are still going to wait. But people like the idea of driving on the freeway to get close to the city, but you're still going to wait. Because at the end of the day, what you need to do is to get people out. The more you can flow out, the better. So this is essentially the idea of flow. So maximum flow and then minimum cuts. Now, so your first theory is over here. They're saying that a maximum flow is connected to the minimum capacity of the individual pipes, which is what we were looking at before. We saw 12, we saw 30, and then we saw 5. So the minimum capacity actually ends up being the maximum flow that you could possibly have. Okay, so that's what that first part of the idea is. So that's the first dot point. 4.1 talks about maximum flow. So understanding that capacity, and they give you a couple of terms here, sinks and sources. What does that mean? They're simply telling you this is source. Source is where the water comes from. Sink is where it will end. Okay, and then the flow is obviously what's in between. Now, once you've got the idea of maximum flow, capacity is how much one pipe can take, which is written down here. The weight, so remember we learnt about weights on each edge. The number on each edge, which we call the weights, can be considered as capacity. So how much can it take, right? What you have over here as an example, on a logical basis, if you're doing this example here, just have a look at the diagram. So you've got pipes, imagine they're pipes. Are they actually pipes? No, they're roads. Okay, so this is 300 cars going that way, 500 cars going from A to D. So the source is at A, the sink is at E. If you had to tell me what is the maximum amount of cars that can be received by the time they get to E, how would you do it? Now we can do it in two parts. There are obviously two pathways to get there. Let's go through this pathway. There are 300 cars that can go here. Great. I've got 300 cars going from A to B. But then from B to C, it can take up to 600. The capacity is 600. But how many cars are actually still flowing from B to C? 300. Because that's all I had from the source to begin with. I had 300, even though it can take up to 600, I only have 300. And then from 300, I'm going all the way down here. How many cars am I expecting at point E? How many cars?
800.
Not 800, because the capacity is 800, but how many cars is actually flowing through?
300.
300. This is going back to the theory again. It's connected by the minimum capacity. That's your max flow. So the minimum so far, even though that was 600, 800, 300 was the amount. So 300 is here, but then you have to also account, well, the source is also connected this way. A to D, I've got 500 cars going A to D, which that tells me this is still 500 going through, but then notice from D to E, I only take 150. So how many extra am I expecting to get to E going down this pathway? 150. So together, at point E, how many cars do you expect in total? How many cars in total? Logically.
Oh, the cars go both ways.
Yeah.
You mean 450 an hour?
450 overall. Because you see, point A had 300 going that way and then 500 going this way. So they started 1 point. But at the end of it, you can expect overall 300 plus 150 gives you the overall at E. Okay? Let's have a look here. So the questions, as you can see, thank you, team. Thank you, Thomas. Thank you. I'm still explaining. Thank you. All right, thanks, team. Here we go. So you've got max flow. You got from point A to point E. There are two pathways to get there. We can see how I got 450, and that's what question B was. Over to question C. This is where it gets a bit more interesting. So part C, you can see it says here, if a new road was being built, so this is kind of like if you were to build freeways here, in this case it might work better, but you build from town D to town C, so I'm connecting now D to C, okay, and this road can carry a maximum of 500 cars, okay. Now the question is, add this road to the graph, which I have. They call it digraph because di means directional graph, so you can see the directions that it's heading to. And then find the maximum traffic flow from A to E overall again. Okay, so in part B we found overall was 450. Question is, by adding D to C, does that change the overall flow? So let's calculate it. Over here, so we still have, at the very top, remember it was 300 to go here, 300 is still going through maximum, okay? And then the arrow, remember, was from D to C. So the graph here is D to C going up that way. Now let's have a think. 300 cannot go through this way because the arrow is in a different direction there. So that means I still have 300 coming this way. So there's still 300 there. But let's have a look now. Starting from the bottom, A to D is 500 going this direction. Now there's only 150 that can go through here. I can push through to go 150 to go here, or technically, if you think about it, these 500 can also go up here. Now there's two ways to think about it. You can split it up as 0 went this direction and a full 500 went that way, because we're looking at the maximum capacity, right? So if we were to take the maximum capacity, 500 goes from A to D, D goes to C, all 500 goes here, and then from C, can they go all the way to E, all 500? Can they make it to E in all 500?
Yes.
In this case, it can. So that's why you would say a total of 500 now gives you a total of 800 cars. That's possible because you've opened up a road that has a higher capacity. Okay, but for all I know, it could have been 150 went this way and the remainder would have gone that way. So 350 could have gone here and the result is still the same, that the max flow is 800. Okay, because when you're saying max flow, you're trying to find, whatever scenario you have, what's the maximum capacity that you can get? Okay, that's the calculation. That's the problem solving part. Okay, now, what's the problem with this technique? So we're always finding efficiencies here. We understood the idea of max flow. We know that the minimum pipe or the minimum connection is the maximum flow that you can get. This was an easy graph. This is a very straightforward sort of networked graph that you can see. What would happen if I increase that to a much larger flow? You see, you don't want to be sitting there trying to calculate one possibility to the next possibility to the next possibility. There has to be a better way to find your maximum flow. And there is. It's a bit slightly tedious, but it's more systematic to do this. So this is where your second dot point comes in. You had 4.1. What is the max flow? Considering capacity, sinks, and sources. So we ticked off that. What is 4.2? 4.2 now gets you to think about what we call minimum cuts. Okay, and they've got this idea, or based on this technique, you can find your maximum flow by first finding your minimum cut. Okay, so first thing is, what is a cut? A cut, okay, so a cut, this is your network. A cut is an imaginary line that you separate the sink and the source. So a cut has to be something that can separate, where, if you imagine as pipes and waters, it has to separate from the sink, from the source to the sink. There should not be any connections. Okay, they shouldn't be able to make it. So in this case here, you can see, if I imagine that I cut this out, there is no way any water from the source can make it to the sink. That's considered a cut. Okay, so I can draw another one. I can do this one over here, but that's not a cut. Why is this not a cut? Very good. I can still get to A, going through from S to C, C to A. That's still a possibility. But even if I did cut that, if I went up and down, this is still not a cut. Because, same thing, S to B, B to A can still be made. That's not a cut. So a cut has to separate the sink and the source. Okay? Now, what's the benefit of the cut? Every time you cut it now, there is a source side and a cut side. Sorry, source side and a sink side. Okay, so if you imagine it separating it out. So in this particular case, this is my source. This is my source. It's all coming from the source. Okay? When you make a cut, what they're wanting you to calculate, and why they call it a minimum cut, is you need to calculate the maximum flow that cut line has touched. So that cut has cut three edges, three main edges. There's this edge from M to A, from C to A, and B to A. Okay, so I'm going to highlight that again just so you can see it on the video. The cut that we've drawn connects these three. We're not interested in these ones here. Okay, so these ones aren't there. It's the cut, because the ending part is what the maximum flow that you can get, right? So here, what is your max flow? You got 1,000, you got 400, and you've got 600. And they're coming from the source side. Okay, the source side. So here, I can see I'm getting 1,000 plus 400 plus 600. That gives me a total of 10, 1, 2,000. Okay? Now each one you can see there's 1,200 that's going here, then at the end it's still 600. This is 1,500, but that only takes 400, so that's obviously the max amount. And then here, even though it's 700, Technically, that should now be 700 there, but we're talking about the max. What is the maximum you can take overall? So you can see that those three, we're only interested in what's the value. So we would normally call this cut 1, okay? And then you write cut 1 is 2,000. Then you have to figure out multiple cuts here. All the possible cuts, your aim is to find the minimum cut, because the minimum cut, the one with the smallest number, total smallest number, is the maximum flow. That's the theory. Okay, so I can do another cut. I can do, this is another cut. Okay, if I do that cut, I'm touching edge S to B, S to C, S to M. So these are my 3 cuts. If I added them together, they're all coming from the source. It says source side out. I'm not calculating from sink side, I'm calculating from source side. You can see 700 this direction, 700, 1500, and 1200. If I added them together, 700 plus 1500 plus 1200, this gives me now 7, 5, 7, 14, so 3,400. So clearly, cut 1 is still better than cut 2. Then you got to think about, are there any other ways that I can separate the sink and the source? I can do this cut. I can try cutting from the top. I'll cut that one. I'll cut, say, I can choose to cut this one, and then I'll cut this way. Okay, so this is slightly different. I'm doing 3 edges again, 4 edges this time. S to B, S to C, and then there's also M to C, and I'm also cutting M to A. So then now I calculate, well, what's that value now? So I've got, again, 700 plus 1500 plus, from here, I can still go from the source. Remember the source side, so if you try to picture separating these two out, the water's still flowing. I can still go 600 that way, and I can go 600 that way. So that gives me a total 600 plus 600, that's 1200 plus 1500 plus 700. That's clearly bigger than 2000. So that means cut 3 is not my minimum cut. If you can come up with another way to cut it, which I can, you can cut it this way now, which is a different cut to this. Okay, so this one was 1, 2, and 3. I'm now cutting 1, 2, 3, and 4. That still separates the source and the sink, and I'm calculating, is it the minimum cut? So here again, we've got 1200 coming from the source. From the source here, that's now 400. I don't calculate this one. Okay, why don't I calculate 600 as well? So this one's the interesting one. I'm going to highlight it again. I'm just going to rub all these ones out. Why do I not include, when I do this red cut here, why do I not include the 600?
Going from the sink.
From the source. Source comes out, the sink is from that direction. Yeah, so to get to 600, the only way is that it was from, this is the side, sink side. This is the source side. So water's always coming from here. Water's coming out, so that's 1200 is calculated for this direction. But to get to 600, it's already cut off. It's not going to reach there. So that's why I don't calculate the 600, because that's on the sink side. This is the source side. So I've got 1200. I've got this side here, that's 400. And then this is 1000. So let's calculate that together now. So that's 1000 plus the 1200 plus the 400, which still is bigger than 2000. So what is my best minimum cut was the first one I did. That's going to be your max flow. So your max flow is 2000. Okay, that's the idea. That's the maximum flow that you could possibly get based on this diagram. And that's what they're trying to teach. In this example, you'll see that there's multiple cuts, but each time, and the way I cut them, I always do the first 2 and then a sort of a curve in between is how I do it. So I usually do the back end, the front end, and then there's 2 in the center. That usually covers most of the cuts, but you may end up with 6 cuts or so. Usually I can get away with 4 to 5 to kind of estimate what the minimum cut is. Okay, so you get a problem like example 3. So example 3, I made a video for this one for you to see. They don't show you the cuts. You have to make your own cuts. Okay, so you have to practice the cuts. And you can see here, I should have, in the videos, you'll see which cuts I've done, but I then calculate which ones has the smallest one, and clearly 7 is the smallest cut out of them all, so that's why my max flow is 7, whatever it is, so 7 liters per whatever it is, but in this case it didn't tell me. I just know max flow has to be 7. So this technique is called the maximum flow minimum cut, which is DP 4.2. Okay, so I'm going to give that as one session. This is the bottom one down here. Once you understand it, there are technically 2 parts that you can do. Okay, have a go with this one. This is a VCA question back in 2011. And if you can do the max cut minimum flow, you'll be able to do this pretty quickly and easily. Okay, and the answers in it should be 700 from memory. You should be able to find the max cut, which looks like minimum cut here, 300, 400. That gives you a nice 700. But if you do it right, and be careful with the arrows, so the bottom one, you have to note that there are actually 2 sources coming in. Okay, so that's what makes it different. But that's a VCA question there. But you're practicing 4.2. So 4.2 talks about minimum cut, max flow. We understood what max flow was, but was there a better way to do it? Yes, there is. Find the minimum cut. And by doing the cuts, you're trying to calculate from the source. That's what's tricky.